All right, everybody. Aditya is ready to give his talk. Let's all come back here if we can and give him the attention he deserves. All right.
Okay, so good evening, everyone. Welcome to the talk on IoT Exploitation 101. So this talk is going to be something like a very short crash course on how you can get started with IoT security. How many of you guys already have looked into some kind of security of IoT devices? Okay, 2 of you, yeah. And how many of you think that IoT devices are secure? Okay. Yeah, as long as they are unplugged. Yeah. So my name is Aditya. I run a startup called Atify and another one called Security School. We specialize in IoT and mobile application pen testing. I've also written a couple of books, like one on Android and the other one coming next month called IoT Hackers Handbook. And I've spoken at a bunch of conferences like Black Hat, OWASP, AppSec US, and a couple of others, and worked through a number of different security and developer roles in the past. So one of the courses that I teach is offensive IoT exploitation. And I've been doing this for the past, I think, IoT for the past 4 or 5 years. And I have noticed a trend between all the speaking sessions and the training sessions. So people 4 years back, they had this notion in mind that IoT devices should be secure, both the developers and the people, like executive audience. But these days, like as you can see, everyone knows that IoT is not secure. Maybe you have seen some hacks in the past. Maybe you have heard of Mirai botnet or any other attack on IoT devices. So the current present-day IoT security is like web security back in 2001 or even before that, when almost everything that you touch has a number of security vulnerabilities. How many of you have heard of things like OWASP, broken web application, or DVWA? Almost everyone, right? So they are vulnerable platforms. Now, if you take any IoT device, most of them are vulnerable platforms. So you can try as many vulnerabilities as possible on these IoT devices. So this is a vulnerability, or this is the decompilation of an Android application for a medical device utility. And all, as you can see, like all the encryption was happening with a password called Bob the Builder. So once you get this password, all you need to do is maybe sniff the communication, use this to reverse or decrypt the packets, which is also something that I'll be showing today. And then another thing happened recently. How many of you guys saw this? Dishwasher had a directory traversal bug. And yeah, so once you have the dishwasher connected to the internet, all you need to do is run a directory traversal attack, maybe get the admin credentials or any other sensitive file on the file system, and maybe start the dishwasher or make it part of a botnet, do whatever you like. Right? So we have seen a lot of different vulnerabilities. Now, if you look at the entire IoT ecosystem, starting from the end user to all the cloud ecosystem, all the mobile application, radio communication, which particular layer do you think is vulnerable to attacks? Exactly, all of them. So you have a number of mobile application vulnerabilities, a number of web and cloud-based vulnerabilities, radio communication vulnerabilities where you can hack things like Zigbee, Z-Wave, 6LoWPAN, all of that. And then at the end, you have hardware-level vulnerabilities like UART, SPI. And these are some of the things that we'll be discussing in this talk, along with the demos. So what is Internet of Things? I think everyone is aware of what exactly it is. So any device that you think is communicating with any other device or collecting data, has a bunch of sensors to maybe monitor things and all of that. So everything comes in Internet of Things. There are a number of different names for this, Internet of Everything, whatever people like to call it. There's also another name for it called insecurity of things, because most of these devices are already insecure. Yeah. And these days, the basic principle behind creating IoT devices is anything that is there, just put a chip on it. Just because it is possible, a product will exist. So anything ranging from like smart egg trays, smart glasses, smart bottles, all of that will exist, like already exist. So this is one of the popular Twitter handles which you can follow if you want to stay updated with all the different things which are currently happening. So Internet of Shit. So this particular handle tweets about all the ridiculous things which you can have with the IoT ecosystem. And this is how current day smart homes or smart enterprises look like. So you buy a number of smart devices and you're prepared for security holes everywhere. Later on, I'll also be discussing, or I think, yeah, after a couple of slides. So the way you start looking into IoT security, and this is the very first thing that you do, and maybe some of you are already aware. How many of you know of Shodan.io? Yeah, good amount. So Shodan.io is a search engine for a number of things, including Internet of Things. So anything that is probably connected to the internet and something that you can also access remotely, you might end up finding it over here. So you can search for a number of things like industrial control systems, dishwashers, refrigerators, toilets, toothbrushes, all of that. And it's really funny, like, do this exercise. Go back to home, go to Shodan.io, anything that comes to your mind, just search for it, and you'll end up finding something. So one particular guy actually found a truck parked somewhere, and it had the default credentials, admin, and he was able to actually move it. And I also, like, while I was doing a pen test, I had this target of breaking into an enterprise through, like, everything possible. And I found this smart coffee machine, which a lot of people have in their home these days. And this smart coffee machine uses a number of technologies like Wi-Fi and BLE, comes with a mobile application. Everything looked good at first, but as soon as you started sniffing the BLE traffic, it kept on emitting the Wi-Fi credentials every couple of seconds. And the enterprise had it on the Wi-Fi network. So, yeah. So you get the Wi-Fi credentials, connect to the enterprise's Wi-Fi, and the game is over. Yeah. So sniff Wi-Fi credentials over BLE. And sniffing BLE is something like really trivial. So you can get a Ubertooth or get a Adafruit BLE sniffer, start sniffing all the packets. And yeah, even these kind of vulnerabilities were found in things like Fitbit and also a number of other vulnerabilities. So they had all your info like collected and also uploaded it to their server insecurely, including a lot of personal information. So yeah. So what does IoT consist of? Firmware, hardware, software, radio, and cloud. And the way to pen test IoT devices is to look into each of them separately and then figure out how these different components interact with each other. So we'll start off with firmware, and we'll later on move to the different aspects, and we'll have like individual case studies and demos in almost everyone except the firmware, I guess. So yeah, so firmware, if you're not familiar with the term, it's pretty much any kind of code that runs on the device. And yeah, almost any embedded device that you see will have a firmware on it. And there are a number of ways to get hold of the firmware. So one of the ways is get access to the device, open up the device, look at the circuit board, figure out ways, or figure out the storage place, like maybe an SPI chip or maybe a NAND chip, and dump it from there. Or maybe while the device is updating, you can sniff the firmware, have it stored somewhere, or or what could be some of the other ways of finding the firmware? Exactly. So in some of the cases, you'll actually find the firmware on the vendor's website. If not directly on the website, maybe in the community or support forums. So yeah, that is one of the ways in which you can get access to the firmware. And once you have the firmware, look at the different binaries inside it, look at what kind of vulnerabilities they have, maybe command injection, maybe buffer overflows, all those sort of vulnerabilities. Also, another interesting thing with firmware is, let's say you want to start IoT security research, you don't have the device yet. So all you need to do is get the firmware and emulate it using tools like QEMU. Anyone has done it before? Used QEMU? Okay, one guy in the back. Yeah, nice. So all you need to do is get QEMU for that architecture, and you can run that firmware, and you'll have the IoT device sitting on the network, even though you don't have the physical device. So you can perform all sort of network-related exploits on that, maybe do even like live real-time IDA debugging, those kind of things. So yeah, also once you have the firmware, use tools like binwalk, which automatically extract the file system from the firmware, and you have the entire Linux image. Look for different things, such as, see. Yep. So look for different things like configuration, private keys. In most of the cases I've seen, like they have their private certificate, all their API keys stored in the firmware just because the developer doesn't realize that anyone can get access to the firmware. So yeah, firmware is one of the really interesting places to start looking at if you want to find vulnerabilities in IoT. And another technique that you can use is you can get two different versions of the firmware, simply do a diff, figure out what has been patched, and you now have an exploit, even though that particular vulnerability has not been published for the previous version. And then you can also do things like ARM disassembly or MIPS disassembly based on what architecture the firmware runs on. Along with QEMU, you can also do things like attaching with GDB or attaching with IDA. So if you're interested in reverse engineering, you can do all of those things with a firmware, even if you don't have the device. So moving on from firmware, let's actually get to the core of IoT. So hardware hacking. And this is like the most interesting thing that I do. So as soon as I get the device, I open it up, look at all the different interfaces, look at all the different chips, and figure out like what all can I possibly do with this. So most of the devices that you see, if they have things like Wi-Fi or any kind of radio communication, you'll find a FCC ID written somewhere on the back of it, or maybe beneath something, or in some cases it might not be there. But chances are you'll end up finding the FCC ID. Anyone knows what an FCC ID is for? Yeah. Right. Exactly. So it's an identifier for any device that ships in the US and has radio emissions, which almost all the IoT devices are. And just by the FCC ID, you can get the internal pictures, you can get the circuit pictures, you can get the frequency of the device, like where it operates. So if you're planning to do things like radio hacking, you know the exact frequency where you need to attack it on. So just find the FCC ID, go to fccid.io, enter the ID, and you'll end up finding like a ton of information. And sometimes the vendors even fail to like ask for a confidentiality report for their schematics. So that's like the most stupidest thing I've seen. So yeah. So once you have this device, start with FCC ID, open up the device, and the first and the most easiest thing you can do is do UART exploitation. So this involves looking for UART pins, which are typically like 3 or 4 pins or pads on the device. And all you need to do is connect it to a FTDI cable. And what you'll end up having is most probably an unauthenticated root shell. So I've connected the device to my system. I'll just speed it up. So this is my device connected at def/tty USB 0. I find out the baud rate of the device, at what particular baud rate the device operates on. And if I see something unreadable, that is the incorrect baud rate. So if you see something readable, that's the correct baud rate. And once you find out the correct baud rate, all you need to do is run minicom. And this is what you'll have, an unauthenticated root shell on the device. So you can change things like TFTP configuration. You can get access to all the files, change configurations. Yeah, pretty much anything that is possible on the device. Right. And these UART pins are pretty easy to find. Apart from UART, there are a number of other interfaces which the hardware devices operate on. So you can look for things like SPI, I2C, and JTAG. And similarly connect those particular individual pins or pins for that particular interface. And we've also written a tool called Artify Badge tool, which is free and open source. So once you have connected it to, let's say, SPI, all you need to do is click on read and run, and you have the entire firmware dumped from the device. So in this case, we dumped, SPI dump.bin, which is the entire firmware. And you can see by running binwalk that now you have the full file system of the device. So yeah, hardware exploitation, if you have not done it any time earlier, it might be a bit complicated to start, but once you figure out what exactly to look for, yeah, it won't take you more than a couple of days to get started and hacking like everything which you have at home, right? Yeah, it's pretty addictive, and it's not a good habit because you'll end up like, yeah. So now we move on to mobile application security, and yeah, this is pretty common. Like mobile application has a number of vulnerabilities from like whenever mobile application started. And I'll just give you a quick demo of what kind of things you can find with the mobile application. So here is a Smart Plugs mobile application, which is smartwifi.apk. So this one. So this is a smart plug mobile application, and you can use the mobile app to control, like turn on the smart plug, turn off the smart plug. And all you need to do is so I ran an Android application decompiler called JADX, which will decompile all of this to Java files. And once you have the Java files, you can go inside the folder name. And in this case, it was a Chinese smart plug. So Hangzhou, and then ZX. And if you open up the file called preferencesutil.java, you'll have the firmware download URL. So you get the firmware download URL from here, get the firmware, and once you have the firmware, you can go on to find more bugs. And also another interesting thing in this same mobile application was it was pretty secure. Like if you looked at it normally, it looked pretty secure. It used AES encryption. And the AES encryption was actually in one of the libraries. So you simply unzip the APK, go to the libraries, take that library, open it up in IDA Pro or Hopper, start analyzing the ARM code. So in this case, there was a function called encrypt data. And there's also a function called AES set key. Look at the different registers, what kind of values they are holding. And if you start analyzing the registers and the values, you'll end up finding, in this case, the AES key, which is this particular string. And once you have the AES key, you can pretty much do anything that you want. So I had the communication captured, and this is the Wireshark packets, wrote a AES decryptor, and you can figure out the exact command the mobile application is sending to the device, or the device is sending back to the mobile app. So pretty much the same conventional approach that you use to pentest, apply it in a IoT ecosystem. And once you also figure out what kind of commands are being used, you can simply take over the smart plug. So yeah. So give it the command on, it will turn on and off, even without any kind of authentication. So that was all about mobile application. And web is pretty much in a similar way. So all the web application security bugs that you keep on finding, apply the same to IoT ecosystem. Moving on to radio exploitation, this can be a bit tricky because you'll encounter a lot of unknown protocols, such as Wi-Fi, BLE, Zigbee, 6LoWPAN, all of that. And you might require different set of hardware and software to deal with all, right? So for example, BLE, you might need Ubertooth. For Zigbee, you might need RZ Raven and all of that. But the process of doing exploitation is the same. So you start sniffing, start analyzing the packet captures, reverse them, and try to replay it. So that's pretty much the whole process in which you can exploit smart bulbs, smart lights, smart locks, all of that. So this is something that we did with BLE. So we started with sniffing the bulb, and as soon as we sent a write request to the bulb, like changing color, we saw how the packet looked like, and we figured out the handle and the value. So handle is where it is being written, the value is what the value is being written. And once you figure out these two properties, like these two characteristics, all you need to do is just write up a Python script. So in this case, we wrote a Python script to change red, green, and blue. And as soon as you ran it, the bulb will automatically start changing colors. So Python bulb.py, and the bulb starts changing colors. So yeah, simply figure out how it is being written to the device, and you can send those commands by yourself, as simple as that. Be it BLE or be it Zigbee. So the same technique we use for another smart bulb, in this case, I think it was Philips Hue. So Philips Hue uses Zigbee for its communication. So you can get one of these. It is called an Atmel RZ Riven. And you flash it with a special firmware called Killer Bee. And now you can sniff, intercept, and modify Zigbee traffic. So we wrote another tool for this called Artify Zigbee Framework, which I think will be published tomorrow. Yeah. So it starts with finding out the exact channel on which the device is operating. And oftentimes when you do this, you'll find like 20, 30 devices based on like what kind of community or location are you in. So we figure out the exact channel, capture the entire packets as you operate the device. So in this case, we found the channel 20, store it in an output file, smartbulb.pcap, storing up to 100 packets. So you do a bunch of activity with the bulb so that everything gets stored in the packet over there. And once you have everything stored, all you need to do is simply replay the packets. So this is with a like highly popular product, Philips Hue. So yeah, set up the channel, what interval you need to set in order to send individual packets, number of packets you want to send, which is 100. And as you click start replay. So all of these tools are open source. You can download it from the GitHub repo. So you'll see that the bulb has started changing colors. Right. So you don't need to even find the encryption key or like exactly figure out how it is happening. All you need to do is simply capture and then replay. And it might even work on some of the smart locks which you have. Right. So I think that's all for the very short presentation. I think it was 15 or 20 minutes, right? Yeah, okay, thank you. So here's what all we discussed, starting with the IoT device, analyzing mobile application, radio communication. And the conclusion is smart devices are not secure. Make sure you pen test them before actually using it in your enterprise environment. And start setting up a security plan for both developers and security engineers if you're an IoT device manufacturer. Also, if you want to download the slides as well as the video demos and some other infographics which we have prepared, you can go to this URL, artify.co/IoT guide. And that's the contact info. Thank you. Yeah. So how many of you will actually go home scared? Yeah. 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 Yeah, so the most serious issue actually depends from like what product we are targeting. So for example, in case of something like highly sensitive, such as an industrial control system, even getting that thing off the grid, like getting it disconnected, is one of the highly critical issues, shutting it down. In case of like things like Philips Hue, taking over something remotely is a serious issue. Or in case of some highly secure or highly commercial product, actually getting out the encryption keys, figuring out how it works, that can be a critical issue. So yeah, it depends from product to product. Yeah. So any other questions? Yeah. Mhm. Right. Mhm. Right. Right. Yeah. So, so those kind of things are, even though they are possible, like let's say if you attack an IoT device, it has a lot of RAM or available, and you can write maybe your own backdoors or pivot points to pivot into other devices on the system. I haven't exactly seen anything so far. So yeah, that is something which I haven't seen yet. Yeah, but that would be like really interesting because once you have that particular thing, yeah, your entire network is compromised. Yeah. Yep. Right. Exactly. Yeah. Hmm. Right. 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 Also, with those kind of devices, another thing that can happen is, let's say, if you're using a normal off-the-shelf router, so it might so one of the things that could happen is that the firmware could be backdoored at the time that you buy it. So that is one of the things that you need to look for. And the other things are pretty much the obvious ones, like make sure you update it like every time an update comes, or make sure you have physical protection set in place. Like even things in case of routers, UART and these things are pretty common. So making sure those kind of things are protected. So let's say if you buy a router from a store, you can maybe add your own hardware protections so that if an employee goes malicious, he does not simply gets in the router, changes some of the configuration, or flashes a new firmware on that. So yeah, yeah, yeah. Right. So I was actually in the same room. Yeah, but I think like even if you are pretty far away with the things like directional antennas, you can pretty much sniff uh, a lot of things. I'm not sure of what paper did I read, but yeah, there was a particular guy who actually sniffed like a mile far for BLE. Yeah, 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 exactly. And also the thing with Ubertooth is, let's say if you're doing a real world pen test, and so there are actually like 3 data channels on BLE if you're actually going to do it. So make sure you have 3 Ubertooths or Uber teeth whenever you sniff BLE so that you capture all the 3 data channels. Yeah. Mhm. Right. Mhm. Right. Right. So it actually depends on like what kind of device are we targeting. So let's say if we take example of maybe a smart plug or maybe a router. So in router, if there's hardware insecurity, the thing is in order to exploit it, you need to have physical access. So unless you have physical access, you won't be able to exploit it. And uh, for things with, let's say, BLE and all of that, so most of the attackers, unless they are in physical proximity, they won't be able to do it. But even though there are things possible. Right. Now they actually can't do anything with it. Right. So unless it's firmware related where they can push an update and fix it, they can't pretty much do anything on it. Yeah. Yeah. Any other questions? Yeah. Right. Hmm. Right. So I don't know of any active movements happening in that space. Yeah, but the other thing which manufacturers can obviously do is, let's say they are releasing a lot of information with FCC, they can simply ask for a confidentiality report for that particular thing. But yeah, no, I don't know of any kind of movement that is happening in that direction.
In order to get an FCC approval, if there's an admin password,
I
let's say
yeah
these things are outlawed, you can't manufacture in the United States unless
yeah
there's some just minimum standards to protect the consumer.
yeah. I wish there was, but
Yeah, a lot of these are like manufactured in like low cost countries.
what?
I was saying like a lot of these things are manufactured in like low cost countries, which are like
Right. So especially like things like even at a lot of commercial devices that you see in Fry's or any other store, if you go figure out the FCC ID, go to fccid.io, you'll find that it's actually a Chinese product.
So it should be an international standards anyway.
Yeah.
Does a country like China have a similar? But they basically have to label things imported to the United States
Yeah.
for the FCC ID.
Right.
Who knows what the auto?
most people will buy the cheapest possible product.
Yeah, and so
Yeah.
I can imagine that the government does know where its aircraft carriers are. They're not necessarily really.
Right. It's actually good. Like OWASP is actually putting together a list of embedded device security checklist, and that should be out in I think the next couple of days. So that is something that you can look for. Or yeah, that I think if the real thing is if the manufacturers actually start looking for that and fix the security issues before actually putting the place out of the market.
If there were standards so that
Yeah.
it wasn't a competitive advantage to skip it,
Right.
then that might help a lot.
Right.
But there's no movement to make that happen.
Not any as of now. Yeah. Not any that I'm aware of. Yeah. Yeah. Thanks a lot. Yeah. Mm-hmm. Right. Yeah. Exactly. So I think not actually connecting any of it would be like really tough in the next couple of years. But at least for the devices that you are connecting, make sure that you really need them before connecting them to your home Wi-Fi or having it within your within your room. For example, talking of Alexa or any other things that in the start when it was launched, it was not sure whether it is sending data to Chinese servers or any other remote servers or whether it is recording your voice continuously, and those kind of things. So make sure that any device that you have in your home or in your enterprise, they are thoroughly audited for security. And yeah, I think that's the only thing.
Companies like LG who are saying, by 2020 every single device they manufacture will be internet.
Right. It will be pretty tough to actually get something which is not internet connected. Yeah. Like firmware? Mhm. So frameworks. So it actually depends on like even if you use anything, what kind of security are you adding to it? So let's say I have XYZ firmware on my particular device. Do I have signature check? Do I have integrity check? If I'm downloading firmware, like if I'm doing OTA updates, am I validating it or not? So for example, even in things like Nest, like Google Nest, there was originally a security vulnerability found by a group called Exploitation.rs. And they found like if you can sniff the communication, so the update was happening over HTTP. So all you need to do is sniff the communication, modify the update package, and you have your own custom firmware running on the Nest device. So those kind of things, like signature verification, integrity checks, all of that. So that needs to be in place, no matter like what kind of firmware you use. Yeah, and things like secure boot, all of that. Hmm. Yeah. So I wouldn't be able to like comment on that, like which is more secure and which is less secure, because yeah, it's like. Mhm. So a number of firmware frameworks exist. Like if you, for example, if you go for things like VxWorks, that will be obviously more secure than what you have like things like Contiki, which is like an open source free one. So yeah, that is something that you can hope for, but unless you thoroughly audit VxWorks for your particular instance, you wouldn't be able to know. Yeah. So as a user, right? So yeah, that's actually a pretty good question. So one of the things that you can do is basically monitor your entire network, like where all the traffic is going from, let's say this particular device, which is a smart home device with this IP. So make sure it's not making a lot of connections to some remote IP unless it's actually needed. For enterprise, there exists a number of solutions. I'm not sure how good they are. So things like Bastille and all of that. So they have these things like if you have a number of smart devices in your vicinity, you can figure out like this new device has been added with a unknown MAC address. But as a home user, you simply have to rely on like what kind of network traffic is happening. Yeah. Network activity is happening. Right. Right. Yeah. Yeah. Right. Yeah. Yeah. Mhm. Right. Yeah, so one of the things that I use is the first thing is that I try to figure out the frequency of that and then look for tools which work around that particular frequency. So maybe there are development tools. So most of the things that we use for custom developed protocols is development kits which actually come with sniffer or that kind of functionality. So for custom protocols, yeah, it's actually a bit difficult, but yeah, it works out in most of the cases. Yeah.
Yeah, there are some tools like OpenSDR and software-defined radio that you can basically monitor the frequency and extract and
Yeah.
and you kind of have to like make some config of what it's trying to do.
Right.
Yeah, yeah, yeah.
Yeah, so Michael Osman, the guy behind HackRF, Ubertooth.
Yeah.
So yeah, for example, if it's, yeah, most probably it will be in that frequency range. So you can get a HackRF and look for where is a spike as you're using the device. So that will tell you the exact frequency that the device is using. And once you have that, you can pretty much try to capture the packet using HackRF and replay it with that same device.
I mean, most of them will use like some commodity chipset and
Right.
protocol because they're buying like a mass. Not sure.
Yeah. Yeah. Okay, so yeah, thank you everyone. Thanks for coming. Yeah.
Cool. Thank you, Aditya, and thanks, Caroline. One more hand for our speakers, please. Thank you all for showing up. It was really cool to have an East Bay meetup for OWASP, so thank you. And just in case you wanted to know, I'm Aaron Sutter, the AppSec manager here. Thank you all for showing up. No, it's really, we feel great to be able to have a space to be able to do this, so thanks for coming here.